Hello everybody, Mr. Rasmussen here. Moving on to lesson 7.5. Essential question. What are exponential functions used to show? Okay, exponential function. Exponential functions are written in the form of y equals ab raised to the x power. So the x is in the exponent where a cannot be 0. So just anything but 0 is fine, positive or negative. B has to be greater than 0, so B has to be positive, and B cannot be 1. So here are some examples. Y equals 3 times 2 raised to the x power. So now for the future here, you have to do exponents before you do multiplication. So you got to do 2 to whatever that is, x, whatever you plug in for x, and then multiply it by 3. This one, the a was 1, so therefore just b to the x. And then here you have a must have been 1 again, and then b is 1/3, which is greater than 0, sorry, and not 1. So there are some examples of what exponential functions look like. Graph y equals 4 to the x. Find the y-intercept and state the domain and range. Use the graph to find the value of 4 to the 1.5 power. So that would be obviously a little bit approximate. So now, here we have 4 to the negative. So I put in x values of just what would make sense. You can put in any of these x values just as long as it's good to probably get some on the negative side and positive side. So you have x being -2, and then y, let's see, 4 to -2 would be 1/16. 4 to -1 would be 1/4. 4 to the 0 is 1. 4 to the first is 4. 4 to the second, 16. And then 4 times 4 times 4 is going to be 64. So let's graph those then. So we have x being -2 and 1/16. So obviously that's going to be very small, very close to just the axis. Let's see. This is hard to get it. Let's just say, yeah, right there. Basically, very close to the, and yet obviously it's going to have to be a little bit approximate as well. So -1 and then 1/4, so it's just a little bit higher. I didn't really demonstrate that a little bit higher, but there we tried to get up a little bit. 0 and 1. 1 and 4. So we have 1, 2, 3, 4. 2 and 16, which I'm not sure is even going to be on the graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we did, I can't remember, was that 12 or 13? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Started the curve there. So there's my last point there, if I really wanted to get a last one on there. So this one's getting closer and closer to the x-axis. So there is your graph for y equals 4 to the x. Now, if we're going to, let's see, find the y-intercept. So the y-intercept is going to be the coordinate of 0, 1. The y-intercept is always when x is 0. The domain. Domain are the possible x values that you're getting out. Now notice, I could have put in any negative value that I wanted, and then it's continuing to go in the positive. So it's just going to get extremely high up in the air, or up on the y-axis, I should say. So what I'm going to put in here is just all real numbers. All real numbers. All the way to the x on the left, to the right. So, I don't know if I said that right. All the way to the left and all the way to the right on the x. Range. Now notice that the range, this is going to get closer and closer and closer and closer and closer to the x-axis, but it's never going to cross over. Therefore, your range is going to be y is going to be greater than 0. So the range is on the y. How far on the y? So it's going to be here on up, basically. So this is just to demonstrate on the graph there. So y is greater than 0 for your range. Now use the graph to find the value of 4 to the 1.5. So that means the x is 1.5. So now I'm at 1.5, and if I go up on my graph, I'm looking at about 1, 2, 3, 4, 5.5. So 5.5 approximately for the value of y. So that would mean that you have a 1.5 for your x and about 5.5 for your y. Now, if you were to actually check that, sorry, check that with a calculator, you put in 4 to the 1.5 power. So 4 to the 1.5. I don't have the greatest calculator to do that with, but just checking here again. So 4 to the 1.5, you should get 8. So obviously that's where it comes in handy to have a more accurate graph. So we should end up with 1.5 and 8 by the graph. So 1, 2, 3, 4, 5, 6, 7, 8. So it should have been about right there. So that would have made sense to have it at right there. Just my graph is a little bit to the right. So kind of a case in point why accurate graphs are very helpful. So now this is the multiple choice question, and what I want you to do with the multiple choice question is when I give you a multiple choice like this, you do not have to write the summary, you just answer the multiple choice in there. You do not have to do the summary though. So just answer A, B, C, D for multiple choice. Write multiple choice, colon, and then write A, B, C, or D. This is for you to answer. Give it a shot. Example 2. So you have y to the 1, y equals 1/4 raised to the x. So again, I just put in arbitrary x values. You can put in technically whatever you'd like, but and then find the domain and range again, as well as the y-intercept. Okay, so here we go. See if I can make a better graph here. 1/4 to the negative 2 power. So 1/4 to negative 2, that's technically the same as 1 to the negative 2 over 4 to the negative 2, which is the same as 4 squared over 1 squared, which is 16. And this ends up being 4. 1/4 of 0 power is 1. 1/4 of 1 power is 1/4. And then 1/16, and then 1/64. So let's see, this one was kind of going in the opposite direction here. So let's get our graph. We have -2, -2, and that's up to 16, which we technically don't have. if I go to the 1.5, remember 1.5 was at 8? So that kind of goes with the last graph that we did. So 1.5, 1, 2, 3, 4, 5, 6, 7. So at least I get one that's a little bit up there, since I can't get 16 on there. Come on. All right, there. So then we get -1 and 4. 1, 2, 3, 4. And then 0 and 1. We have 1 and 1/4. And then 1/16, which is really close, and a 1/64, which is even try to be closer, but get the idea of getting closer and closer to the x-axis. Use the graph to estimate. So let's get the domain and range first. Domain, I could have put in any x values, so we're going to go, we don't need the brackets when it's just all real numbers. Because you can go and put in any negative x value or any positive y value and still get a answer. Now the range is going to be, so notice that it's still from the 0 on up because it's going to keep going. So this is going to be y is greater than 0. It's never going to be actually hit 0 because it's just going to be 1/64th. And then it's going to continue to 1 to the 4th power, 1 to the 5th, 1 to the 6th, and so on. So let's double check here. I think I have. Yep, we're good. And now, -1/4 to the -1.5. Well, we actually did put that on there, and that's at 8. So we didn't actually have to estimate that one. So you end up with -1.5 and 8. But yes, please, if you're not doing it with pen on a computer, try and be as accurate as possible with your graphs. The next one here is a open response question. So again, like the multiple choice, this is for you to try it out and to put your answer in the summary. You do not have to do the summary of what you learned. It's you put the multiple choice answer and then you put the open response question answer. So it's giving you the function, but talking about depreciation, and let me see how you do. All righty. Have a good day, and we'll go over more in class. See ya.